Hello, everyone, and welcome to Ohio Energy Project's Careers in Energy Virtual Field Trip. My name is Kelsey Beach. I'm going to be your moderator today, and we are excited to have you join us and tour a solar farm in Wapakoneta, Ohio. We are going to be learning all about solar energy, how energy is harnessed and transformed into electricity, and we're also going to be hearing from an entrepreneur in Ohio who's working to provide schools solar energy education supplies. So before we get started, we want to welcome all the classrooms joining us virtually and go over a few housekeeping items. If you have any questions during our field trip, you can post those in the Q&A box via Zoom. If you're joining us via YouTube, there is no live chat. So if you are on YouTube and you want to ask questions, you can go back to your email and join us via Zoom with the link provided in that email. So along with our classrooms here today, we also want to thank the NiSource Foundation for hosting the Careers in Energy program. And we want to give a big thanks to the Eitri, Foundry, and the Shared Power Network for helping teach us about solar energy and careers in this exciting field. So before we get to the solar farm, I'm going to introduce our host, Jamie, and I'm going to share a little bit of background information on the Eitri Foundry. The Eitri Foundry is an employee-owned company that's been deploying solar projects to help uphold sustainable projects, improve social responsibility, and promote local economic development. The Eitri Foundry has achieved their mission by working with local utility companies to figure out how to utilize solar technology to help communities generate their own cost-effective renewable energy. Eitri Foundry develops, designs, and works with local labor forces to install utility-scale projects that range in size from 1 megawatt to 18 megawatts. So with all of that in mind, we want to introduce Jamie Wilcox. He's going to show us the ins and outs of some solar arrays at the Wapakoneta Solar Farm. So Jamie, welcome. Thank you so much for joining us today. If you want to start out by kind of introducing yourself, talk a little bit about your background, and then tell us a little bit about the development of the solar farm that we are looking at today.
Sure, absolutely. I'd be happy to. So welcome everyone to the Wapakoneta Solar Power Facility here in Wapakoneta, Ohio. My name is Jamie Wilcox. I'm a project coordinator at Eitri Foundry. So we commissioned this site last year. It just went online I believe it's in June. And this thing right now is power. It supplies about 18 megawatts of DC power. So it's rated at 18 megawatts DC. And it is annually able to produce about 19,000 megawatt hours per year. So that's a lot of energy. It's a lot of energy, and you can't really tell from where we're at right now. I've got some video to show you after coming up shortly here. You can't really tell how vast this area is. Completely covered with solar panels. This site specifically is about 22 acres. Each one of these modules here behind me, we've got about 46 1,000 of these covering this whole area here. Each one of them, just does its own little part. Each one of them is about 390 to 400 watts each. So when you put them all together on this massive site here, you get enough energy, good clean energy to really make a difference. So that's why Wapakoneta wanted to build this site. Mainly was to power some of their big, got some big manufacturing companies here in town that they use a lot of power. So they wanted to try and get them some clean power.
Awesome. Thank you so much. So
Sure.
we do have a couple of questions from our audience. So our first one is from Jeff. He wants to know what the process is for choosing a solar farm site and how do you go about protecting the land that they're going to be placed on?
Oh, absolutely. That's a very good question. So in terms of choice of land, we will, as a developer, we go and look for land that is either not being used for farming. I mean, sometimes if it is being used for farmland, the owner will opt to use it for solar instead. But usually what we'd love to find is land that is either occupied by a landfill or land that usually previously may have been somewhat contaminated by, maybe there's an old chemical factory or some sort of treatment factory. We call those brownfields. So they're sites where really you're not allowed to build homes on them. You can't really occupy them, but you can use them for something constructive, such as solar. So the two go together really well, solar and brownfield sites. You also really want to be close to a place where you can sort of plug the energy into. So you can have a great site out in the middle of nowhere. And if there's no existing lines to take that power over to the people who need it, it becomes much more cost prohibitive to want to build in a place like that.
Mhm.
So the second part of your question, I love that question. We, in terms of how do we care for the property, how do we make sure that we're not having a detrimental impact on the property that we build on? We do two big things. I think the first of which is maintaining the existing stormwater and wastewater runoff that would naturally occur in a place like this. We really want to make sure that by installing the panels, we're not causing excessive water to build up and start running off the land, and which would bring a lot of silt and maybe other unwanted things into local streams and rivers. And we don't want to impact the other habitats of the other downstream life. The other thing is, if you look around us, you'll see this site is not necessarily, it doesn't look like a golf course here. These are wildflowers, wild grasses, many of which were specifically chosen as native species that often complement each other and help. They help the especially pollinators, but a lot of other insects that like to, just that they utilize plants like this.
Perfect. Awesome. Thank you so much. Our audience cannot help but notice the overcast day today. So Pat wants to know how many megawatts are being produced on an overcast day like today.
That's a great question. So in the heart of the summertime, when the sun is at its highest angle in the sky, I think even if it's dense cloud cover like this, I think you can still get up to like 50 to 75% of the peak capacity, even on a cloudy day, if the sun is very high in the sky. On a day like this, where we're getting into fall, the sun's kind of getting closer to the horizon now, I think it's probably closer to 30%. And then in the wintertime, it'll probably drop down. A very cloudy, snowy day in the winter, you'd be dropping down to 20% of your total, your expected sunny day output.
Okay.
So right now, I'll break it down for you. If this site's rated at 18 megawatts DC, and I believe it's that equates to 17 megawatts AC, which I can answer some questions about that later if you'd like. They're not the same. So on, if we're operating at about 30 or 40% of 17 megawatts, you're looking at about, I think between 5 and 6 megawatts AC coming out of this thing right now.
Okay, great. Thank you so much. We have a couple more questions before we'll go to our next spot. So Enola wants to know, how long are the solar panels good for, and how often do you have to replace them if you do?
Yes, I love this question because there was, to me at least, there was always a lot of misconception growing up. When I was young, I grew up back in the 80s and 90s, so I'm old. But there were a lot of questions about how long are these things, how long are they going to last? And they actually last 30 years or more. So a lot of the newer technologies in solar manufacturing, they've eliminated a lot of the past I'd say problems with solar panels, where there may have been, water maybe was able to get in behind some of the laminate, or maybe some of the connections were not quite weather resistant enough. But now these panels, these are expected to perform at a very productive level for 30 years, and they may even last even longer than that.
Okay, excellent. And then going along with that, how many years has this solar farm, you kind of mentioned it at the beginning, but how long did it take to build this solar farm? And then how many other solar farms are there in Ohio, or how many are does your organization have?
Yeah, so we built this site, I think it took just under a year.
Mm-hmm.
It all comes together pretty quickly when you've got a good engineering team and a great, you got a good subcontractor to work with. If everyone, in our company has a great deal of experience, and they know how to make projects like this come together without a hitch. So this one went very well. It took just under a year to build. Our company, we have about 40 megawatts of utility scale solar power installed in Ohio right now, and we're a small company. We just started about 5 years ago. I just came on board last year, but they have done about I think 8 separate municipalities in Ohio have reached out to Eitri Foundry and asked us to build solar fields like this. So we're very excited about it.
Awesome. Okay, great. Thank you. So we are going to pause the questions for now, but we have some more for our next spot. And as we move over to the transformer, we are going to be able to watch a really cool drone video of this solar farm. And then we will get back to Jamie, who's going to talk a little bit more about the transformer and the array's connection to the grid. right, so that video, you could see kind of a larger scale video picture of the solar farm, and you could see how it was constructed. And so now we're gonna transfer over back to Jamie, who he's now at the transformer. So Jamie, could you talk a little bit about what the transformer is, and then also give us a little bit more insight into how a solar panel actually works and its connection to the grid? And then also after that, would you address some of the misconceptions about solar energy?
Absolutely.
All right.
Absolutely. So I hope you like that video. That was actually this site that we're at right now. And that really shows you the scale of just how large this area is. And especially how much work went into completing this project. So behind me, you'll see these big gray boxes. I'm colorblind, maybe I'm wrong. Are they brown or gray? Sorry. So these are the transformers. They take all the electricity that comes from each one of those modules. And as I told you before, it's very low power on each module. And those modules are all tied together. And those cables are now run underground to this transformer. And what the transformer does is it's actually going to step up the voltage. So there's two components to electricity, two main components. I'm sure some of you may be familiar with. There's amperage, voltage. If you multiply them together, you get watts. Watts is usually how we talk about how much power we're using in our day-to-day lives. So the transformer, the reason it does that, you might be wondering, why do we want to increase the voltage? But the reason is we need the voltage higher so that we can bring it over to the substation here. Now, the substation, it's already got power coming in from other sources. So you've got power plants in the area burning fossil fuels, natural gas, nuclear plants. All those other sources of electricity are dumping energy onto the substation. So what the transformer here does, it's actually going to try and mimic the same voltage, the same frequency as well as the electricity that's already on the substation, so that we can just layer them together seamlessly. And the substation from there, the electricity, it continues its journey through some other equipment and eventually into your homes, businesses, things like that.
Great. So how does your organization then have to work with the local utility companies to come to an agreement as to how that can be used? Could you talk a little bit about that?
Oh, absolutely. So like I was mentioning before with Wapakoneta, they've got a lot of manufacturing facilities in town here. They have a pretty high demand for electricity. So I think one of the main reasons that Wapakoneta wanted to invest in solar was because they wanted to essentially, market this to those manufacturing sites to give them a more affordable option for electricity, as well as keep that cost controlled over the long term. Because that's another great thing about solar is there's very little maintenance to do with these panels. Things do happen, things do break down, but the long-term maintenance cost with solar is very, very low when you compare it to something like a power plant that's burning fossil fuels. So that's a huge consideration. Absolutely, when you're deciding whether or not to build a facility like this, is who's going to use the power? Is there an appetite for that much energy? If not, is there a way to tie it back into a substation where it can be delivered to places further away that perhaps can use the power?
Okay, great. Yeah, thank you. So kind of along with that, we have a question from Abigail. Abigail wants to know, how are the panels and equipment protected from damage? And if a panel does get damaged, where does it go?
Right. So that's actually a good question, because I don't know, some of you may have heard there was a tornado that came through Wapakoneta not too long ago. Luckily, it did not damage too much of this site. I think there were maybe 13 or 14 panels that had maybe been shipped or cracked just because of some flying debris that had landed on them. But if we can try to spin around here, I'll show you something. One of the most underappreciated aspects of solar, which is the racking. Now, the most important thing you can do for these panels is stop them from moving. Now, you probably hear the wind in my microphone right now. What typically what typically happens when solar panels are not installed correctly, and I think this is probably one of their main failure points, is you'll get movement, you'll get vibration along this whole row. You look down there, you see how long that row is, and the wind that's blowing across there for years and years will continue to vibrate this panel and this racking. And if they're not installed correctly, if this racking is not robust enough to stop that movement from happening, the panels eventually will wear. They'll wear more quickly. They can crack. Connections can become loose. But aside from things like that, how we protect against normal wear and tear, yeah, your biggest threats definitely things like severe weather, hail, tornadoes. Lightning is not really so much of a consideration. Everything here is grounded very well. If it ever gets hit by lightning, it's immediately going to be it will immediately be discharged into the ground. But yeah, overall, in a climate like this where we don't get hurricanes, yeah, hail and tornadoes are the biggest like threats to these things.
Okay, great. Thank you so much. Very interesting. We have one more question before we move on. This question is from Corey. He wants to know what natural resources are used in creating the solar panels.
Oh, excellent. Excellent. So the layer that you see on top here, it doesn't look like glass because it's not reflective, but it is. So that's right there. You've got silicon dioxide, which is sand. We've got aluminum framing. We've got steel framing. There's the copper and all the wires. So there's quite a few not harmful natural materials that go into producing these things. The one area that actually does the magic, which is the semiconductors underneath the glass, I honestly could not tell you what those are comprised of, the actual composition of those materials, but I can explain to you how those work if you'd like. I think I wanted to do that when I brought you over here initially. If we don't have any other questions, do we have another question that you want to?
No, that would be great. Yeah, if you could explain
great.
that would be awesome. And then we'll go to Jake.
Certainly. So the panel itself, you've got a layer of glass here. And if you look really closely, you'll see a bunch of little tiny metal strands underneath the glass. And underneath those metal strands, you've got this just dark layer. And that dark layer is your semiconductor layer. So the semiconductor, what it does is when electromagnetic radiation from the sun, which we see as light, interacts with the semiconductor, it makes electrons want to move. It gives them the potential to want to move. And the little strands of wire in here give them a place to move to. So if you come around to the back of the panel here, any of you that know basic electricity, electronic circuitry, you've got your negative, positive, anode, and cathode. The electrons are going to want to move from one and to the other. So when you get back into the panel, the mechanics of the panel itself, when the sunlight interacts with those semiconductors, there's one layer of semiconductors that sort of wants to urge electrons to move away, and then another layer that wants to allow them to come back. So that sort of completes the circuit. And that's you see the wires coming out of the back here. That's generally what's happening there. So
perfect. Thank you. No, that's very helpful. We like to learn about the ins and outs of that. So that was perfect. So before we move on to our next spot, Jamie, we are going to pivot and we're going to introduce Jake Koos. He has a nonprofit organization, the Shared Power Network, and the Shared Power Network gives teachers and students the opportunity to explore solar power using the Green Energy Machine. So the Green Energy Machine, or the GEM, has applications across grades K to 12, Each kit is supplied with an 100-watt solar panel, a 12-volt battery, Bluetooth data collection system, a utility cart, and customized mounting systems. And the GEM can provide opportunities to explore solar energy, sustainability, physical science, technology, and engineering, electricity, circuits, math, weather, and more. So we are super excited to have Jake here with us. And Jake has a gem to show us, and he's going to take a couple of minutes to share with us about the Green Energy Machine, and how, if you are a teacher in Ohio and you are interested, how you could potentially receive one. So welcome, Jake. We are so glad to have you, and we will let you take it away.
Awesome. Thanks, Kelsey. I really appreciate it. Hi, everybody. I'm Jake Coast with Shared Power Network. And like Kelsey mentioned, we work with schools and educational nonprofits here in Ohio to bring solar energy to the classroom. And so Jamie did a fantastic job of walking through what a larger scale solar can look like and do, and how it actually functions. One of the fun things about the Green Energy Machine that I have right here in front of me is that we can wheel it into the classroom, share it between campuses, and actually have K through 12 students come up, touch and feel a solar panel, look at the inner workings of the system, and begin to understand at a very close level how everything's functioning, what this does, and that it in fact does work here in Ohio. I think it's really fun to see really large solar installations like up there in Wapakoneta, so that you understand these cities and the businesses that build those systems, they wouldn't bother if it didn't work here in Ohio. And so that's one of the things that I really like to focus on with students, is that it works here in the state, even though we don't always get a ton of sunshine. Right now I have an umbrella over my computer because it's raining just a little bit, but we're still producing enough electricity to run this light that's sitting up right here. And so one of the things that I love to showcase with students is that you can immediately see what's happening. So there's a little bit of sunshine coming through the clouds up there, and you can see some images from our classroom visits. But if you come up here and start to block the solar panel, even just a little bit, you'll see that light dim and go off. It's because there's a little bit coming through, but not a ton coming through the clouds. So if I move that newspaper again, that light will come right back on. But on a day like today, we're getting into fall. It's nice and cloudy. It's drizzling a little bit. You don't have to cover too much before that light will totally kick off. So I cover about a fourth or a fifth of this panel, and that light kicks off, but it'll come right back on there when I uncover it. So that's one of the things I like to immediately show students, is that all you need is for sunshine, the photons that are in that sunshine, to hit this panel to kick off that electrical circuit that Jamie was talking about, to be able to harness that and utilize it in a light bulb like we have right here. And I know some of the students that are watching right now have seen the Green Energy Machine before, and I'm hopeful that each time that they get to see it, utilize it, understand how it's working. It's just one more example of how solar energy works here in the state, and how it'll be a bigger part of your future, as we see more cities like Wapakoneta going in on these larger scale installations, and more companies are asking for this. So it's something that's exciting to be a part of, and we really enjoy being on the front end, working with K through 12 students to kind of start that process, so that when you all get to points in your careers and your academic studies, that this is something of interest, that it's a really viable option here in the state.
Yes, fantastic. Thank you so much, Jake. And I can say, having seen it myself, it is super cool. And I can totally see how, if you're a classroom teacher, I would want my hands on one of these. So if you are a classroom teacher watching, Jake, could you talk a little bit about how they might go about getting one of these green energy machines?
Yeah, absolutely. So we're lucky enough that we won a wonderful grant from IGS Energy, based here outside of Columbus, where they have provided funding for the past couple of years to do 20 green energy machines each school year. And we're going to receive that funding for this coming school year as well. And so if anybody's interested out there in getting a green energy machine for your school or for your district, feel free to reach out to the Higher Energy Project, or my information will be in the follow-up email after we close out this session here today. But we'd just love to hear more about your school, what your interests are, and how this might be able to fit. We've seen everybody from pre-K all the way through, 12th grade capstones, where they're using this system, whether it's just to showcase how solar works, or, seniors that want to make it an automated system and turn it into a rover, which is something that I don't know how to do, but I really hope that those students have the opportunity to make that happen. So yeah, if you're interested, feel free to reach out. We would love to hear more. We've paired up with schools from, as far north as Toledo and the Cleveland area, talked to schools down in Cincinnati and plenty around central Ohio. So we're always looking to expand our footprint here in Ohio.
Perfect. Fantastic. Thank you so much for joining us, Jake. And again, like Jake said, we will put any contact information in the follow-up email after our VFT today. So thank you so much, Jake, for joining us.
Yeah, thanks for having me.
All right, so we are going to kind of make our way back to Jamie, and he is going to show us kind of the side of the panels and the inverters. So he's going to talk a little bit more about how those work, and then we're going to answer any final questions we might have, and then that will wrap up our VFT for today. So Jamie, kind of take it away, show us where you are at this next part of the solar panels.
All right, yeah, we are a little further into the solar field here now. We've walked a couple hundred feet into the panels, into the panel rows here, and I wanted to show you the next important stage after we capture that power off of the modules. We tie all these wires together, and they're all going to come back into these inverters here. What the inverters do is critical. They're going to take that power from the solar modules, which is coming out as direct current, and they're actually going to synthesize an alternating current, which some of you may know what that is, and I can answer questions about it afterward if you'd like. So this thing does a lot of work. Direct current is coming out of the modules. It's outputting alternating current, and after that, all this power goes back into these lines, and there are over 100 of these inverters on this site. So we've got a lot of lines going back to one place. So these lines go back to they're like breaker panels, but we combine all the power back into one box, and then all of those boxes, you can actually see them a little further down the row though if you have good eyes. All those boxes will then go underground and lead to the transformer that I showed you a little while ago.
Fantastic. How many people, Miriam would like to know how many people it took to build that solar panel field.
Oh, you'd be surprised. I mean, there's definitely a lot of hours that go into building it, but if you consider if you consider the manufacturing effort that goes into making the modules and the racking, the design of the whole project itself, the financing of the project, the construction of the project, and the project management, which is what I do, it's hundreds and hundreds of jobs went into this.
Very cool.
And thousands of hours of work. Tens of thousands, if not more.
So on that matter, could you give us a little bit more, could you talk to us a little bit more about your background? So we have a couple questions about, they want to know from high school on what kind of led you to this career path?
So it's actually, I took an interesting career path. I initially was very passionate about weather. I've always loved the sky, and like understanding weather is like this very energetic phenomenon that's above our heads all the time. And I went to school, I studied physics and math for a few years. And then I became more interested in studying economics, and I got into business. And I've worked in logistics, I've worked in finance in the last 10 years. And I slowly realized that I really enjoy working with my hands and being outside. And this is sort of a happy medium for me, because I don't necessarily get to work with my hands in project management, but I get to be around people who are, and I get to enjoy it more being with them and watching them do it and helping them get what they need to get their jobs done quickly and efficiently. So yeah, I've been around the whole I haven't done everything, but I feel like I've done a pretty diverse array of jobs since high school. Yeah.
Excellent.
But
What does the day on your job currently look like?
right now, my days look like, well, I've actually got 2 projects active in Ohio right now. So every day I'll try to circle up with our subcontractor and find out, how things are going on the construction site, understand if there's any challenges going on that day, any concerns that we need to talk about with our company. From there, I usually get on a phone call with Eitri Foundry, our company, and we discuss just business every day, like how where we're headed as a company, what sort of details we need to address every day to keep things running smoothly. Definitely being on the phone a lot with suppliers and subcontractors just to make sure that things are staying on schedule. And you want to make sure that everything gets built the way that the engineers have spec'd it out. So it's a lot of attention to detail. You get to be very passionate about a project and understand it very, very intimately to feel comfortable about being there and being very, very responsible for the success of the job.
Absolutely. Perfect. Okay.
Quality of the job.
So we have 2 more questions. I think we'll have time for. So the first one is, do you have any information on where high school students could get training, either during high school or after graduation in the solar industry?
Absolutely. So one of the big subcontractors that we work with here in Ohio is Vaughn Industries. And they're a great place. They have a great apprenticeship program. They have a whole training center on site. And they've got a great culture there. They're very open. They're very open to helping people learn. And they seem to really enjoy bringing people in and teaching them how to be not just professionals in the solar industry, but linemen and electricians in general. So much so that I may be tempted to learn a bit from them in the future as well.
Advice to get interested in the industry.
I'm sorry, you broke up just a little bit there. Could you repeat?
Sorry about that. Our final question is, what advice would you give to students interested in a career in the solar industry?
Yes. So there's definitely a lot of different avenues you can take. If you're choosing a degree in college, I would say if you are dead set on being in solar, if you know that this is an industry you want to end up in, I would say try to pick a segment that you think you'd be interested in. Say if it's business, like on the finance side or on the construction side, pick one that you want to focus on and make a plan to achieve your educational goals, either through college or trade school. But I would say also don't just focus on one aspect. You really want to get a good idea of how the whole industry works together. And it's a great way to give yourself some leeway when you get out into the job field and you progress through your careers. If you decide maybe down the road you want to pivot from construction into project management, starting early and getting an idea of what that entails, and even getting some education and experience under your belt, even though it's hard work trying to do, 2 things at once while you're in school. I think it opens you up to be able to do more down the road. And again, it helps you understand more about what the job entails and what to expect once you start doing that as a professional career.
Absolutely. Well, thank you so much.
Yeah.
Thank you, thank you, thank you. We learned so much from you today, and we really appreciate your time. We also want to thank all of our classrooms for participating in our virtual field trip today. And again, we want to thank Jake with Shared Power Network and Jamie from the Eitri Foundry. It was super exciting to be with you, and we enjoyed learning all about the solar energy industry. A recording of today's trip is going to be available on the Ohio Energy Project YouTube channel, and we are going to have some additional VFTs coming your way in the winter and spring of 2024. So make sure you check out our website for additional updates. So thank you again, Jamie, and we hope everyone has a great day, and we'll see you next time.
Bye, everyone. Thank you.